Dear viewers and subscriber, thanks again to watch our YouTube channel Max the Service. Max Service is the only YouTube channel to take care of providing videos with proper information like documentation, architecture discussions, and working with practical examples for beginners and expert to learn by watching videos on Max the Service YouTube channel and start leading in the industry.
Dear viewers, first of all, I would like thank you to stay in touch and subscribe my YouTube channel. And again, I would request to subscribe if you have not, and also provide your valuable comments. If there is any improvement, I will try my best. So today in this session, we will cover in detail what is Dockerfile, how to create Dockerfile, all the commands used within a Dockerfile. That would be great. We will be doing some examples. We will be working with real-time project. Then we will start how to create image, how image actually works, all the layers used with Docker images. I will explain the purpose of every image. Also, with some example, I will providing some queries and commands to show you all of it. Then what is container and how to containerize the application, how to run container from image, how container works, all the aspects of container I will be discussing in this session. So please watch this complete video. After completing this video, you will be a good technical leader of Docker. You will be able to grasp the full potential of Docker. Actually, it is crucial to understand some of its fundamental objects and concepts. So these are Dockerfile, Docker image, and Docker container actually are fundamental concept. So let's start with what is Dockerfile. Okay. Okay guys, just to save our time, I have created Dockerfile, and remember that we have using our demo project from the start, and I will keep it working on it, and whatever we will be keep learning, I will updating this and also committing these changes on the GitHub. Sorry, yeah, GitHub, and you can download and review, and you can also add your commits, you can also add your changes by creating branch. For GitHub queries and commands, we have also another tutorials available on the same channel Max Service. You can also go through that video as well. So it is very good to learning from the scratch within a one project, which is the with the name of demo. And I have created Docker file. You can just simply because this Docker file is created on the main folder. Just you can go and create new file. Just you will write Docker file, and that's it. It's not a matter of case sensitive. You can create with small or capital words, whatever you need. And because we already have created file and we don't need to create anyone else. So one thing more, remember that if you have already installed plugins with your IDE, either it is VS Code or other IDE, then you will be able to see this icon when you will write Docker file. You don't need to add any extension. Okay, so we don't need actually this file as we have already created. And here I have also wrote all the commands. One by one I will be uncomment and executing, and I will be showing you with the explanation of every command. So first of all, we start with the command of from, and remember that whatever or whenever we are going to create Docker file, this command should be the first command of your Docker file. Okay, uh, and also you can also have multiple uh, from command as well. Whenever you have from and subsequent commands, and then you can also again add from command. Okay, so docker daemon thread will execute from the sorry, top to bottom, all the instruction one by one. So let's start with the working with the first command, which is from, and this command actually build your image from the base image. Definitely, whenever you are going to build an image, there must be an base image. Let's suppose if you are going to execute your utility or software or any application, you must specify, okay, I am going to create this further image, but my base image will be Ubuntu, or my base image will be JDK, OpenJDK 17. Even you can also use Python. If you are working on Python, then you have to mention here your base image as a Python library. Otherwise, if you are working on Java based project, then you have to mention that, okay, from JDK 17 onwards, my source code will be working. If we will not mention JDK as a base image, our application will not work as expected. Okay, if nothing I do anything else, then I just only I can build my image with the from command as well. You don't need to do any commands. So every command have its own purpose. So let me show you how to build the image from this only single command. We will also adding a terminal. Okay. Okay, I have to stop. Okay, because it's not allowing to execute shell script, so that's why I have stopped this. Okay. Okay, simply I will first, as we have covered two approaches, create image, build image from Dockerfile. Also, the other way we have covered the way from just to run commands like this, Docker build demo latest. We can also use anyone. So first of all, we will be looking for any images exist. Okay, guys, because we are on this main folder. First of all, we have to move into demo. Okay. Okay. Another thing, because I'm not running Docker desktop, because Docker engine is not working, so that's why I'm not able to execute any command. So in this case, if you get such kind of error, then you have to run your Docker first. Okay, now I will try again. Here you can see we have lot of images already available, and we have to delete all these images before moving forward to avoid confusion, because if we have already lot of images, then it will create some confusion. So let me delete all of these first. We go into Docker Hub and delete. First I have to check how many containers I am running. So let me try if I can delete already running containers. We can also do these with the commands. Just to save time, I am going to delete all the images. Okay, we don't want to waste time because I have to check why I cannot delete these images. I can also try to remove volume if these are linked with, if there is any build Docker Hub. Okay, guys, so first of all I have to let me check it again. So there are Now a few images left. I will work on it separately and delete these. So I want to create image from JDK 17. So let me execute the command. How this name is happening, because we have added settings. Here you can see, here is the image prefix and here is artifact. Artifact is the demo and prefix is max the service. And where is that? Here is. Here is image prefix and here is artifact demo. Okay. So now images being generated, and then we will be able to view these images available here as well. So definitely it takes some time. Okay guys, we have created image demo with the from JDK as a base image, and the next command is maintainer. Why this command is used, let me show you. Maintainer actually is deprecated, and we can use, instead of maintainer we can use label. And let's suppose we can use author is max the service. So when we will inspect this image, it will show us in the inspection. Let's suppose if you want to view who is author of this image, you can inspect image and it will show you the name of maxi service. So we will be covering when image will built, and I will show you. So instead of because my concern is to just save time, and I'm moving to the next command, which is run. Actually it specifies the it execute command in the container. Okay, when you run a container and you want some commands to be executed, as you see that first we have image, then we have container. Now we are building image, and when we run image as a container, these commands will get execute. Okay, so let me add some examples to show you. Like if I want to execute command, what we can just add echo. Let's suppose if I want to add echo, what I want to echo. Let's suppose I want to echo sorry, any uh, environment variable like home. I can echo what is home of this container if I have already added home variable, already set it. So it will print home. I can also echo uh, welcome to the Max the service YouTube channel. Whatever command we can execute under this uh, shell. Eh, Okay, so next it's CMD. Okay, CMD. What this command actually do? It specifies the default command to run when the container starts. If you want to run a command when container starts, then this is also helpful. So for examples, we you can also use a CMD like echo and hello maxi service. Okay. uh, Actually, what the difference of CMD and run is, I will also explain when we will doing some example. uh, you can also use a CMD like same as I have showed you with the uh, printing home variable, any other variable. You can also do this. I mean, you can also run any command using CMD as well. Okay, next command is expose. Okay, expose. This is very important command if you want to building an image which will be running as a container and serving as a application. So let's suppose if you want to expose your port of your application. Now I'm working on a project demo, and when I will run this demo as a container, and I will be accessing this demo project with some specified port. It will be available default port which is 8080. I can also use any other than 80. Let's suppose I'm going to run with 8081. So through this port, because I'm going to expose by myself. Okay, if I want to expose this port other than, let's suppose, whatever, I will be able only to access with this port. But remember, what port you are specifying, it will be with the range of given, like either your application support that port or not. Okay, next command is env. Env, if you want to specify your environment variable, okay, then you can also use env. Okay, let me add an example of env, uh, like let's suppose, please give me a second. Let's suppose if you want to set, okay, you can also use same as label, and you can also set your Java home, your Tomcat application server variable home. You can also set any other key value pair. So let me give me a second so I can show you proper with example. Env, where is en? Yeah. Let's suppose you want to set your Java home, then you can just simply add Java home this, and you can also execute this command again. It must print like Java home. Okay, Java home. Okay, let me delete this one. So we will be checking how run works and how cmd works. And next command is, guys, add. What actually add? It copies files from the host to the container. Okay. When we will use command add, it copies whatever we want to add from. Let's suppose if I want to add my source folder and destination is demo, it will copies this source folder into demo folder. Most of the time we use source, copy source into source. Okay, and then next command is copy. So this is a this serve as a same. We want to copy source to source. Okay, the difference is uh, one command is used to copy from remote. If source is remote, then we will use add. Okay, actually use add for remote resources and archives. If you have, let's suppose, not on the local machine and you want to copy from the remote, then you will use add. Otherwise, you will be using copy. So because we are using the same machine, so we will be using copy. Okay, here let me copy the commands. Yeah, here you can see we can use both, but because we are working with the same machine, we will be using copy. So copy, actually it will copy build whatever jar we have here, okay, into demo.jar. It will rename and with the current directory it will build a demo.jar. Okay. Okay, next is our next command is entry point. So what does it mean? Actually, entry points specifies the entry point of the container. Got my point? I mean, when container starts, where is the entry point? It will the start and execute the command given in this entry point. Okay, it will start Java application and with the manage.jar command, because we already have copied demo.jar, and then it will start executing demo.jar, nothing else. Okay, so next command is volume. Guys, I think we have to build an image with this and see either we are able to accessing this application with 8081, are we getting echo this, and also we are getting this Java home. So we'll be covering one command one by one. So first let me start with this. So let me start building this. Okay, failed to solve, build failed to solve, match metadata, Docker, latest, access denied. Okay, may authorization, server image, insufficient authorization. Okay, then I have to use this one. Okay. Okay, let's see either if we have available image on the host Docker Hub. Yes, we have available, and there is no any container, and you know the command how to run the container. Here I am going to running container with this 8081, internal is 80 demo. Let me start this. Okay, so demo application is running, and let me test either we are able to access it or not. Localhost 101. Okay, what? Hello. I have to check either my container is working. Yes, our container is working, and if I 001, oh sorry, yeah, hello demo. So we are able to access this application with this, and we have successfully executed all these commands. And let me show you. Let me inspect the image and show you the author name and other commands either run successfully or not. So here will be inspect. Let me find author. Here you can see we have labels authors and Java home, cmd echo Java home, and we have copies demo.jar as well, and our docker daemon thread execute this demo.jar, which is available and running now. And what other thing I can show you? Okay, okay guys, I have showed you everything. Where here you can see authors, and the host port is 8080. Here this one is internal port, and expose port is 881. And let's start with the next command, volume. So what is volume? Can we check Java home? Yeah, here is. You can see environment variable already set at Java home as well. And also let me show you latest, and mhm, wait. View container usage, pull, push. Okay. So let's start with the next command, which is, let me stop this one and delete this one so that we will be able to run from the scratch. Okay, you can see here are two volumes attached with the other application, and we will be able to see another volume with this image when we will write volume command. Okay, guys, we have executed many commands in Docker files, and we have also reviewed, and I have also shown you when container runs, and if we go for inspection, then you can see, let's suppose if I'm going to run this image, and now here a container must be available, and I can show you In inspect that you can see your cmd echo java home. You can also execute this command and see your java home like uh, uh, java home. You can see here, you can also view your already set parameter environment variable, and you can also inspect and see if you have also set env java home. Here you can see as well. Here is, and you can also see your labels, whatever label we have already set. The author is maxi service, and everything we can set and verify in the inspection. So next command, volume. Here you can see we don't have set any volume, and you can also see your files here, and you can also set your volume under dev anywhere else. So let me go into the Docker file and add volume. Well, let's suppose I'm going to set volume here. Actually, volume instructs creates a mount point with the specified name and marks it as holding externally mounted volumes from native host or other containers. Let's suppose you can set this volume as a external storage. You should use volume instructs to expose any database storage area, configuration storage, or files and folders created by your Docker container. You are strongly encouraged to use volume for any combination of mutable or user serviceable parts of your image. Actually, some constraints, notable things about creating volume. If your container is working on Windows, then a non-existing or empty directory. When using Windows-based containers, the destination of a volume inside the container must be one of non-extension or empty directory, and drive other than C. You can set your volume. This is just to specify precautions when you setting volume, and changing the volume from within the Docker file. You must consider if any kind build steps change the data within the volume after it has been declared. Those changes will be discarded when using the legacy builder. When using like a build kit, the changes will instead be kept. You can also using JSON formatting, but take care list of parsed as a JSON array. You must enclose words with double quotes. Never use single quotes. So these are the some tricks, and you must be consider when creating volume. So let's suppose I have set it volume, and in running container I have shown you the there is not available volume here. Okay, is it's a null, and let me execute the commands again and see build. Let me refresh. Sorry, I have to stop or delete this container, and now I have refreshed images. Okay, and I believe if I run this image, it must have a volume available. No, still we don't have volume, and let me verify it again. Let me delete this image as well. Actually, you can see it's 44 minutes ago, and let me see. Okay, there is change. with volume, and let me build it again and run container. Let's see. Inspect volume. Yeah, here you can see we have already added data. Under this folder, whatever your container will create any data for and use storage this data folder, not other than this. So next command is, guys, what is user command. Actually specifies the user to run the container. As if you use user, it instruct user instruction sets the username or uid user id to use when running the image, and any run cmd entry point instruction that follow it in the Dockerfile. So to execute a user, let me also share example with you. Okay, next command is user command. What actually user command does, user instruction sets the username and optionally the user group to use a default user and a group for the remainder of the current stage. The specified user is used for running instruction, like if you are this user will be able to set entry point, run some commands, can run some cmd commands as well. But note that when specifying a group of the user will have only specified group membership. Any other configured group memberships will be ignored. So let's suppose if you are using Windows, and you want to create a new user like Maxi service, then because you have to first create user, and here is good thing that I am again using from command, and because I'm going to create user from micro Microsoft uh, Windows Windows Server Core. Okay, Microsoft Windows Server Core, and here I will execute run command to execute this user, which is net user, and slash add maxi service. Okay, maxi service user will be used to run any command, can use entry point to also can run some cmd or any other command this user can run. So just I have to confirm that this one, actually it is soft micros Microsoft Core. Okay, so let's see either we are able to run this. Can we create this user from Microsoft Windows Server Core or not? So let me stop this, and also for your uh, understanding, I have to delete this container to avoid confusion. I am also going to delete these images as well. So let me build an image this with this new user. Okay. So this is creating problem, fail to resolve. This is a fail to resolve, use source metadata docker io pull access denied, repository does not exist, and then okay. mm, Microsoft Windows, let me use this one then. No. Pull access denied because this repository not allowing me to pull this user, because I'm using this as a base image. Definitely when I will create new user from this base image, it is not allowing me to create user. It is not allowing us because now I will be using uh, Linux environment, because as we are working with the WSL and 2, and we our Docker host is running on uh, Linux environment, and I will be using Ubuntu latest. Okay, and the command I will be using apt get -y update, and again I will run command group add -r user and user add -r group user, and I'm using user. Now let's try again. You can see here pulling Ubuntu latest and to create user. So it will take some time to create user, and now we can see image should be available here. You can see 9 seconds ago, and let me run this as a Docker container and see here it is running. Okay, and now the new user is available. uh, Let me check if we can see from here. Here you can see config. So in configuration we have created user. So this user or create a new one can execute any command once log into this container. So I will show you how this user can execute all these commands later on, because we have short time and we have to complete all the commands. So next command is uh, working directory. Work directory. So what is our working directory? What the purpose of this working directory is? It actually sets the working directory for any run cmd and point copy and add instruction that follow it. Let's suppose if right now we are our working directory is demo. Okay. uh, other than other than demo, if you will go back, let's suppose in maxi service, and you will run some maven clean install, it will create problem because our working directory is demo. So we have to move him to demo, and then we can run clean maven clean install. It will work fine because we are on the right working directory. So we must define our working directory when we start working with the Dockerfile. So our working directory, let me show you. I already have copied. Yeah, you can see our working directory is demo. So we will be using demo. Demo. Yeah, this is the only simple. You can also add slash as well if you want to. Okay, next command is uh, it's mean whenever I will execute any command. Let me elaborate little bit more. Let's suppose if I'm here and I want to execute any command, then my working directory will be demo, not any other than that. Argument. Okay, arg. ARG actually used to define a built-in build time argument. Let's suppose if you are going to provide during build time your image, if your image is going to build and you want to pass some argument runtime, okay, then you can use this instruction argument. Okay. Actually, argument defines a variable, like you can use user and provide some value like maxi service, and uh, it will user key must be provide value maxi service as a runtime. And you can also but you can also use multiple variables defined, like one argument user, second argument is build version, let's say it's a 1.1, whatever version 1.1, whatever you can provide at runtime, because you can read these values runtime from different uh, environment. Like if you have a dev environment, production, q environment, you can also read different values from different environment variable. So one thing we need to know, it is not recommended to use build time variable like if we are passing, let's suppose credentials. Okay, credentials like ABC 1 2 3, whatever is, you don't you cannot use this argument to pass like GitHub keys, user credentials, etc. build time, because this can be seen with the using of Docker history command. When you anyone access on your container and can run Docker history, um, it it will be shown to that user, and your secrets will be exposed. Actually, environment variables define using env. Let's suppose if already you have defined like env here, this one, and again you are also providing, let's suppose I have provided env Java home, and again I am going to provide argument Java home with different, let's suppose D. It will override. Now your environment variable will not be available longer. This will be override with this new value, whatever you will add. New value added will be override env. Okay, so take care when you are going to provide argument. Take care to provide mentioning the key that will not be available before that argument. Actually, Docker has a set of predefined defined arguments as well, like if you want to provide HTTP proxy, ठीक proxy, or you can also add FTP proxy, no proxy, whatever. These are some predefined uh, uh, argument. Okay, so uh, argument it can be passed at runtime, and let me show you. I have added some argument like user, because we don't have already provided user key, and there was a build version. Yeah, sorry, argument build version 1.1. So it you can also provide like this. So if I run build and again run container, then I can also view these values as well. Okay, let's see what is on build command. On build command actually run instruction when your base image going to start build. Let's suppose you are you are building this image, and whenever anyone else will be using this demo as a base image, then these instruction will be running. Let's suppose you want that, okay, whenever uh, this demo uh, image will be base image, and someone else going to create from demo to or any other image, then I want to copy Docker file into data folder. Okay, then actually this is um, a source and this is destination. Okay, whenever you want some instruction to be executed, then you have to, let's suppose you want to copy and docker file into data. Whenever anyone within your team or anyone will use this demo image as a base image and create another image, let's suppose if someone is going to use from demo latest. Okay, whenever anyone will be using this as a demo image as a base image, then before building this another image, whatever you name it, it will start copying this Docker file to data folder. So this is actually the purpose of on build adds to the image a trigger instruction to be executed at later time when the image is used as a base image for another child, for another build, the trigger will be executed. Any build instruction can be triggered as a trigger. Okay, guys, let me show you because we have used orgs, and if I go to use Docker history demo, you can see here all the argument you have created. That's why whatever you have configured, you can see everything. So that's why it is prohibited to use argument for secret information, so that anyone else will not be able to view and misuse. Okay, guys, I am leaving three commands. One is stop signals. Uh, you can use sig kill, sig term, whatever. And the second is health check, okay. And third is shell. I'm leaving these three instruction Dockerfile commands for you to have some practice and share your knowledge, share your experience in this video. So if you have any issue with these commands, I will explain in the next video. Otherwise, I hope you will be able to execute and utilize in Dockerfile. Just I'm not going to work with these because I want you to do some practice and see what happened with all these instruction. So everything is in this file, and I will commit these changes into GitHub, so you can uh, uh, utilize directory repository on the GitHub. You can download and create another branch and start working with it, because we will be continuing with this demo project. Whatever we will be learning, we will be adding into this. Okay, guys, we have covered all the Docker file. What is Docker file? All the commands with example, and now we are going to move on Docker image, and let's discuss and do some practice and see how image works, and know what are the image layers, everything. So let's start with Docker image, which is most important second object of Docker. So guys, please don't forget to subscribe and press the bell icon and select all options to receive all the notification as well. Container image is a standardized package that includes all of the files, binary, libraries, and configurations to run a container. Here you can see in this image we have different layers containing different kind of material, like at layer 4 we have source code. Whatever application we are going to work with, source code would be available on layer number 4. And layer number 3, all the dependencies. Let's suppose we have developed application in Java, all source code will be available. If you can change your source code, like in Java application, if you want to change the dot class on production, on deployment, within a var or jar, you can change, go and extract all var or EAR, even enterprise archive. You can extract and just replace the dot class file in source code. Okay, in traditional in methodologies, we have been doing like this. And dependencies, you can also change your dependencies at layer 3. All the applications have their dependency, like if you are going to implement with Spring application, and there is any other utility that would be available here. And here you have requirements, what the projects and application is going to develop. All the requirements are available at layer number 3, where image, when we start container, actually application start reading from this layer. Okay. And here is layer number 1, which is fourth layer, right? Actually one layer. Here is runtime. For example, if you are going to deploy your Java application on that machine, you must have Java runtime. You must install JDK to make the runtime, Java runtime, available to run that application. Even is that Linux, Windows, whatever operating system you are going to use. And then this one is basis. Actually this layer contains some basic commands, and our management manager, application manager, which needs to be do some basic like system level dependencies and requirements are lie on the layer number, a basic layer, which is a base layer, image layer. Okay. The another good thing is, as we have layers and we can reuse this image, as I explained, what if I have this whole image available on system 1. Okay, then what? Should I have to rebuild another image, or can I use any layer from that? Yes, you can use any layer. if, Definitely, if you want to use all the layer, you can run another container with the same image. But if you see, okay, I have source code, different dependencies might be, it is 100%. If you have different implementation, you must have different dependencies as well. But you also have the requirement as per this application. Definitely your source could have different implementation, and that might have different dependencies, and requirement also depend on all this implementation and dependencies, right? But guys, if you are going to again run the same image and application within a Java, right? Then you must have an you don't need to make available another runtime. This is the beauty of layering of this image. You don't need to layer this basic layer. You can utilize these two layers if you are going to uh, build and run another container. You can share this layer, these two layers. You can share runtime. Let's suppose if you have installed jdk 17, and you can run on that machine more than one application, because you need runtime and that is available. And this is related to only your operating system. You can also share this layer as well. Layering is made possible by content addressable storage and union file systems. While this will be technical, here is how it works. After each layer downloaded and extracted into its own directory on the host file system, right? Like let's suppose it is on a host file system, extracted in different layers. When you run a container from an image, okay, if you run container from this image, a unified file system will be created, okay, here, from where layers are stacked on top of each other, creating new unified view. When you start container from this file system, okay, its root directory is set to location of this unified directory using chroot, okay. When the unified system is created, this one is created, in addition to the image layer, a directory is created. Another directory is created here, okay, on the same host, uh, for the running container. To run this container, this directory will be created. This allows the container to make the file system changes while allowing the original image, this original image layers to remain untouched. Okay, guys, got my point? This enables you to run multiple containers from the same underlying image. Within this image, if you run one container, you have seen one file system is created, then a container initiated from this. And to make this container fruitful be running in the future, a directory will be created from where this container can do some changes. If you go and run another container, the same scenarios will be happen, and this base image will be remain untouched. Okay, guys, after understanding layers of image, we will do some practical example how the base image exists, because whenever we build a new image, it becomes a base image, okay. From that onward, if you start committing and installing with that container and committing those changes within that container, it's called adding layers to that image. Let me show the example. Let's suppose we have a base image on Docker registry or Docker host First of all, guys, you have to download and install desktop Docker, or at least Windows subscription for Linux, so that you can start working like this. So right, in this session I am using Ubuntu console because in previous session we have been using VS Code. We also used Docker desktop as well. So right now I will be showing the changes, all the images, container, whatever practical example I will be going with there. I will showing you on both on Ubuntu terminal and well as on Docker desktop. So let me start Docker desktop parallel. In the background it should be start, and let me uh, start with, okay, first command is to get the base image, the Docker, okay, run. I'm naming it name like base container. Why base container? Because from the base image I'm going to create this one, base container. Ti, what does it mean? Only I mean interactive, to interact with the console, and T mean it will get you navigate to that terminal as well. Now you are on the root of this Ubuntu operating system with Mahtab Abbasi. Once I execute the command with manage ti or dash ti, it will navigate to you on the container console. So what the name of image, base image we have already on GitHub. Uh, it will look into local machine. If it is available, downloaded already, then it will start working container, base container. Otherwise, it will first download and it will run your uh, new container with the name of base container from Ubuntu base image. So let's start and see. Yeah, unable to find image locally, so it will start downloading. And guys, it will navigate to the terminal of Ubuntu. And once we start container, as we have discussed in previous slide, that it will be created its own directory system where we will be downloading the node.js or any other library, and then after committing, it will be adding another layer to this Ubuntu base image. Now we have downloaded new image Ubuntu, and you can see from Matabasi we are also navigated to terminal of this container. Here we can see we can use ls dir, whatever we have available here. So now I will first try to update in this new terminal so that everything will be available, and there might be no use of anything else regarding to running and upgrading this container, running this image. So these are the basic commands we first start. Okay, done. Now I will install apt install node.js. Now this image, this node.js server will be downloaded on the new container directory. It will not available outside of this container, because we are in this container terminal and now it is being downloaded in this container specific to be used within this container. Okay, now I will commit this node.js to the image so that I can start working with this image Ubuntu with already installed node.js. To do this, first of all, I will check, okay, if node is installed, and let me try to console it. Log hello max the service. Sorry. Mhm. Here you can see Okay, we have node installed, and we can also echo whatever we have. We can print log. And now the point of understanding, once I will commit these changes, it will add another layer to previous image downloaded with the name of Ubuntu. Okay, now let me commit this. Docker, sorry. Okay, guys, remember that you will not be able to run Docker related commands here. Remember that, because you are on terminal and you can download, install other related to terminal. If you are on Ubuntu, then all Ubuntu related commands you can execute here. If you are on Windows, then Windows related commands you can execute here. Now I will have to uh, go to another terminal, and first I will see, okay, I have started new container, is it running or not? Docker ps. Okay, we have running on the port 8080. You can see here 5 minutes ago we have started this one, Ubuntu, as the with the name of base container. So I'm going to commit these changes because I want this node downloaded as a layer to the Ubuntu image. To do this, so that anyone else from my team, if start running container, node will be available in this image Ubuntu. Anyone else don't need to install it again. But remember that this Ubuntu image will be the base image. You can start working this. It will not be it will not get change or anything else. Okay, so to do this, let me docker container commit message add node base container, and now I'm going to create new image. After committing these changes, I will be having node base. Now you have node base image with node installed, but Ubuntu with it is a base image. Anyone working starting work with base image Ubuntu, no one will be having node, but starting with node base, it is Ubuntu but with node layer available, node installed. Or you can also use Ubuntu, and you can also start with JDK Python instead of node, but this base image will remain same. Okay, let me show you in the example. Here you can see this base image will remain same. Okay, and you are actually you are going to change the runtime. You are adding layer, you have runtime installed like node.js, and I can use base image Ubuntu, and I can start with JDK. I will install JDK. Base image will remain same, but the rest of layers will be changed accordingly. So now to check either I can see these changes as a layer or not, I will do log docker image history of node base. Great. Here you can see. Here we added the another layer into this image node base. If you will check the history of Ubuntu, you will see we also have added here. Okay, now guys, we have seen that how we can add how we can use base image and create new image with addition of some layers, and let me check, either we can use base image docker run node base node E, as we printed with the Ubuntu. And now I'm going to try to check new created node base image either have installed node or not. Console.log hello max the service, sorry. Mhm. Yeah, here we have again. Okay, if now we can just remove the container what we have. Let's suppose, let me check how many containers we are running now. Docker ps -a. Here you can see we must have two container, base node and base container. Okay, here is base node, sorry, node base and base container. Clear. I can remove. Okay, one thing more, guys. If your container is working and you are going to remove that one, okay, rm base container, it will ask you to stop this. If you don't want to stop and just remove with the force, you can use this one. Now you will see there is only node base. Okay, guys, same thing I can show you in the Docker desktop. But one thing about the base images, a base image is a foundation for building other images, right? You can use Ubuntu for build to start building and other images. There is no any change within Ubuntu. It is possible to use any images as a base image. You can also start with the making this base image. Okay, guys, you can share this node base and make sure that this is our node base. Whenever you start your container with any other dependency, just create another image. The command, let me show you, we have used. Here is, here you will write node base and here you will write new image name. And this node base will be always base for everyone, and another whatever you are going to add, commit another changes to that new image, it will remain changes. So in this example, we probably will not deploy this node base image as it doesn't actually do anything yet, but it is the base you can use for other builds. Okay, guys, so I can show you all of this. Here you can also see node base we have also available here, and I can also delete from here as well. These are the containers and these are the images we have downloaded Ubuntu and Nodebase. In previous session we have worked with the maxi server demo with using OpenJDK. So we can also stop and download delete here as well. And okay, guys, so this using base image is rarely used. You will never experience, but it is very important to understand how the layers of images work and how we can add layers, more layers within an image, and how we can use base image and run container from them with the rest of the addition of dependencies or runtime, whatever layer we are going to add. And in the example you can see this is read write from this container layer. As we have seen that we have committed from this layer and new layer is added with already what we have layers within the base image, are because we can make any image as a base image and start working from that. So in next video we will be working on Dockerfile. All the commands, all the information, instruction, whatever configuration we use in the Dockerfile, I will be explaining you, and I please stay touch and subscribe if you have not, and also share in your circle so that other your colleagues, your friends, all also beginners, learners can get benefits, because I'm trying my best to with important things to be highlighted, and everything I want to highlight and explain you, so that if you start learning and doing practice with max the service, there will be nothing to left. So that I try my best, and also please do your comments so that I can improve myself, my videos for you, if you believe. Okay, guys, we have covered two major main concepts in Docker, which is Docker file and Docker image. And now we start discussion on containers and see how container works, what are the important parts of container, how to run container from image, everything. So let's start. Before starting, don't forget to subscribe and press the bell icon to receive rest of notification we are going to provide you in this channel. Thank you. So let's start with the discussion of Docker concept. So first concept, why Docker container came into existence, what the revolution in development and deployments come with the Docker concepts. So today we will be discussing how and why we need containerization, right? So to start with, let's suppose we have been asked to develop a full stack application where we need front end like Angular or React, with the backend APIs like we can use Spring Framework or .NET, and also we will be needing a relational database, which is MySQL. So let's suppose we are going to develop a killer application, or killer web app, or we are going to develop a full stack user management system, whatever is. It should be contains all front end, back end, and database. And the same time, we need developer to start on the same application, so that we can get develop things fast and in a better way. So another developer start working with the Angular, and let's suppose Spring and MySQL. Okay, they started development, but they forget to sync with the versions. Like developer one started with the Angular 8 and Spring Boot 2.3.6 and MySQL 8.0.1, and the other developers start working with the Angular 12 and Spring Boot 2 and the uh, MySQL with version 5.0.1. So they have started and they are ready to deliver their application. So what is challenge here? Here, when we ask them, okay, please merge your code and give their application for quality assurance testing or for UAT, whatever next process in SOP. Okay, so what is the next challenge? Let me share in other slide. Okay, now application is ready and developer one merge into repository and also developer two merge into the same repository. They merge their code so that application can be merged and deployed. So you can see we have development environment, staging and production environment. Here we also have some installation of Java, JDK, Java, Spring Boot libraries, Angular, MySQL. We have to take care of the version, what we version developer 1 has been started with, developer 2 must be start with the with those. Let's suppose they have merged the code and there is no any further testing, and they started deploying their application on any environment, development, staging or production. First, definitely they will deploy on the development environment so that unit testing can be performed. But guys, you can see here we have Angular 8. Okay, it is good that we have almost the similar version of Angular 8, and we have Spring Boot 3.5. But here developer one have 2.3, and MySQL 2.0, and here is also 2.0. Okay, but here conflicting with Spring Boot version. And also we have let's see the code of developer 2, it is also merged, and there is also variation with the version of uh, Angular, a big version. It's a latest one 12, and it's a old version 8. So when we merge and you will deploy your application, there will become a conflict, because there will be application not working properly. There will be some conflicts on deployment, because your environment had different version, and your developers have different version. So this is the one challenge we have been facing in traditional environment. Okay, later on we realize, okay, we have to sync before merging our code, that we have a same version, and we also have installed JDK and MySQL on the all three environments same version, so that there are no more conflict when we deploy the application. So this is the second issue with the traditional environment. So let me show you the third one. Third challenge we have been facing in the traditional environment, it was when more than one developer start working with their own versions, and they started merging in CI/CD or in your parent branch, they will get conflicts. It's another issue which need to be fixed before merging their code in the main repository, so that before, because it is the basic and main benefit of central repository, so that these conflict can be fixed, so that rest of application will be deployed smoothly, so the from all developers have same version. But we have to take care. Okay, again, whatever version we have approved with, let's say we have approved 12, Angular 12, then here we again have 8. So this is another issue we have to take care. Whatever versions we have agreed on the development machine, on developer 2 or on developer 1, all those same versions should be available on our deployment environment, where we are going to deploy our application. MySQL, JDK, Angular, whatever tools and technologies we are using, the version should be same. So this is, guys, third challenge we have been facing in traditional environment. So let me show you how container come into the picture and resolve all these solution, and overcome all these challenges. Here, guys, let me explain and show you the challenges and issues we have fixed with the latest technology, Docker container. Okay, here you can see, first of all, we have to agree with the file. Okay, we have to mention all the versions. We are starting with development, like we have Dockerfile, where we have to mention, okay, when we start our development and start running our application, it should be automatically download and make available. Okay, we don't need to install all these version manually here, but here in traditional environment and old development methodology, we have to download, we have to make sure all the versions. If developer one version with some version, then all the rest of developers should make sure that they have to download and make available on their development environment. Most of the time, when you initiated the application and you have downloaded and it is available on your local environment, any tools and technology with the set version, might be possible after few years there would be not available link, there might be possible not available that library to download and make the possibility for the development to start. So To overcome this, this is the first thing we have to just mention what version and what the technologies we are going to utilize. Then we start building an image. From Dockerfile, we have command to build the image, and then we run image as a container. Okay, so here you can see its container responsibility. When we start image running as a container, it will download all the mentioned version. Same similar version it should download and start working with these. Your application will be running on the mentioned version in Dockerfile. And again, another uh, a good benefit of containerization is you don't need to make surety, okay, I'm going to run a container on a different machine and I have to make sure all those versions are available there. No, you don't need to do this, because it's container responsibility when you run your image as a container, because it is running on a Docker engine. Okay, and it is isolated from your operating system. Okay, it is not dependent, it is not relying on your operating system to ask your operating system, okay, make available all these versions, so I'm going to run and make the application available for users. But here, when you run your application, you have to make sure all these versions are available on your operating system. So here we don't need to do all this. It's container responsibility to run with all available version on Docker engine. How Docker engine operating system works, because we already have covered with the concept of virtual machine and containerization. Actually, from one machine, we virtually separated one operating system with the virtual machines. It's mean we have one operating system, but virtually we divided more than one operating system. And then actually container virtualize the operating system, not machine. So let me show you clearly in next slide. In this diagram, it is clearly defined. Let's suppose we have three containers. One is app1 and one is app2 and a third one is with app3. Every container has its own in runtime environment, right? Uh, because it is all container running on a Docker engine, container engine. And you can see we have only one operating system, one hardware. We don't need to more than one virtual machine, like we have one hardware and we virtually divide one hardware into different operating system, then it's become virtual machine. When we virtually divide operating system into different environment, then it's called containerization. So you can see we have app1, app2, app3. At your app1 is running on Node, your app2 is running on Go, and your app3 is running on .NET. But you can see you have one hardware. Hardware mean your server, your machine, development machine, whatever you are working on, or any environment you have deployed your application. You have one operating system, either it is Windows or Linux, and just you installed Docker. This Docker engine will help you out to run more than one containers, but it's container responsibility to manage all the libraries and dependencies isolation way. App 1, all the dependencies and libraries have in its own container. So it is isolated from app 2. But it is very good that we have one operating system, one engine, and running more than one application, but with different libraries, different version, different. Every container have its own dependencies and libraries. So this is the concept, major concept, our containerization. It actually help us to modernize our development, and it has boosted up uh, enhancement, performance from every aspect. We have utilized this technology nowadays. Okay, so the main points of containers are self-contained, isolated, independent, portable. Self-contained mean every container contains its own dependencies and libraries. Okay, and other aspect, isolated, yes, it is isolated. There is no any conflict, even though if you have node with in this container with a different version, it will not impact with this container already running node with different version. And it is independent, it is not dependent on even on operating system. Okay, if operating system did not have node installed, then your container will not get any problem. It will its own get the environment and start running your application. And fourth benefit is portable. You can also, if your container is running on a Linux, Ubuntu, you can also shift your container on Windows, and you can run as a you can run that image as a container on your Windows operating system. So it's containerization. It's your container responsibility to download and start with those runtime environment. You don't need to do any installation of further dependencies or libraries within that container. Okay guys, thanks for watching this video. If you have watched the complete video, definitely you must understand what is Dockerfile, what is Docker image, what is Docker container. Now after completing this video, I am pretty sure you are able to containerize your any application, even that application is Python with Node.js, Java, whatever programming language you are using. So please keep in touch and stay tuned, and also provide your valuable comments so that I am trying to provide my best. And let's connect in another video. Bundle of thanks. Bye.